My name is Francesca Scopetti. It is March 12th, 2021, and I will be reviewing Case Study 1 and Case 4. Starting with Case 1, the first question asked by the patient was, I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally during exercise? Our muscles store glycogen as fuel for muscle contractions. This uptake of glucose into the muscles is controlled by a hormone called insulin. Insulin is secreted by our pancreas when it detects there is glucose in our blood, and that signals it to uptake. Our muscles are insulin sensitive tissues due to this fact that they take up glucose from the bloodstream when sufficient amounts of insulin are present. This storage of glycogen is used as our muscles' energy source for when needed by exercise. It can also be stimulated by an adrenaline stimulation, our fight or flight response. When skeletal muscle contract during exercise, this increases our calcium and our AMP levels, triggering a cascade of signaling to the stored glycogen to convert into glucose 6-phosphate, and that will enter glycolysis. Under anaerobic conditions, no oxygen present, the pyruvate that is generated is reduced to lactate, and that travels into the bloodstream and goes to our liver. Once reaching the liver, it can be reconverted back to pyruvate by an enzyme called lactate dehydrogenase, which then pyruvate will enter gluconeogenesis, and that is to produce glucose that our skeletal muscles will take and store. McArdle disease, which is another name for your diagnosis of this rare deficiency of muscle, that glycogen phosphorylase. It's a disease that cannot break down glycogen stored in your muscles. So your muscles cannot break down its stored glycogen, which means the muscles cannot get the glucose it needs to maintain and to work best. This deficiency only impacts your muscle metabolism under anaerobic conditions, aka exercising, because muscles never support our blood glucose, our homeostasis, due to the fact it lacks the enzyme glucose 6-phosphatase. Your second question was, I really like to take long walks. Will I still be able to do this with my friends? Light exercise will actually be very important for you. Some symptoms may arise. You may find that you are able to take long walks with your friends with minimal side effects, as it is a light exercise. Typically, patients with this disease only experience symptoms through strenuous activity. Strenuous activity can cause damage to your muscles and kidneys, so best to avoid these types of activities. That being said, you might find at times you get tired faster than your friends on your walks. You could also experience muscle cramping, muscle pain, stiffness, or even weakness. A routine of low to moderate exercise is going to be important in maintaining the ability of using your glucose in your body. Your third question, as a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose levels? No, that will not be necessary. It is more essential to do so before exercise than it is in the evening. It is, however, to be very important that you maintain a specific diet that is rich in carbohydrates. This response will help to help to improve your tolerance to activities throughout the day. So best to work with a care team member to get you on a regimen with supplements, performing light exercise, and eating or drinking specific amounts of sugar before you do exercise. Fourth question being, do I need to worry about producing excessive lactate during intense anaerobic exercise? As stated before, stay away from intense anaerobic exercise. I do see your thought process on why you would think this, but it would make more sense that you would not produce lactate because your glycogen does not break down at all. That being said, neither is true. It has been studied, and the conclusion was found that lactate release of someone like yourself with McArdle syndrome will phosphorylase deficient. Okay, excuse me. So your lactate release is very similar to someone who is healthy. For someone like yourself, lactate uptake is more than the lactate released from exercising. The lactate released from active muscle is derived solely from blood glucose, whereas a healthy person, it's going to come from glycogenolysis. For case study number 4, given the symptoms that we were presented with in these 4 hereditary diseases, I was able to eliminate glucose 6-phosphate dehydrogenase deficiency pretty much immediately. Glucose 6-phosphate dehydrogenase deficiency does not present with any of the symptoms unless their red blood cells are exposed to certain chemicals. Symptoms arrive in these patients that are exposed to certain foods, medicines, stress, or bacterial or viral infections. Symptoms for glucose 6-phosphate dehydrogenase deficiency are anemia, jaundice, fatigue, shortness of breath, dark urine, enlarged spleen, and rapid heart rate. The last 3 hereditary diseases, galactosemia, hereditary fructose intolerance, and glycogen storage disease, were all very similar and hard to differentiate. These 3 all have similar symptoms that present in patients, the main symptoms being the hypoglycemia and enlarged liver. Galactosemia is the next hereditary disease that I was able to eliminate with these symptoms. One of the symptoms listed was blood glucose levels increase after breastfeeding, but she cannot maintain blood glucose levels within a normal range during fasting. Galactosemia patients, once weaned from breast milk and switched to lactose-free milk, their blood glucose levels even out. So during fasting or removal of breast milk, the blood glucose levels in a patient with galactosemia will return to normal. The reasoning why I was able to eliminate galactosemia. The last 2 hereditary diseases were the ones that were a challenge. Hereditary fructose intolerance and glycogen storage disease were very difficult for me to pick the correct answer. These 2 diseases are very hard to differentiate. They're very similar. Through the different readings and references, I got even more confused, but the hint given in the case with epinephrine being administered helped me to choose an answer, which I concluded that hereditary fructose intolerance is the correct diagnosis. Both glycogen storage disease and hereditary fructose intolerance present with the fasting hypoglycemia. And the glycogen storage disease, due to the fact that the hypoglycemia can be mild in patients and delay diagnosis, deterred me from choosing the glycogen storage disease as my answer. The hypoglycemia also tends to go asymptomatic as long as the patient is fed frequently. The reason why I had a difficult time choosing the correct diagnosis is, though, that to diagnose glycogen storage disease is due to the lactic acidemia and also due to the fasting hypoglycemia. Reminding myself of the clue given, epinephrine breaks down glycogen in our muscle cells, hereditary fructose intolerant, and the reason why patients have a fasting hypoglycemia is due to the lack of the free phosphates, impairing their fasting metabolism. A reduction in the free phosphates levels will impair their ability to generate ATP in the electron transport chain, decreasing ATP production. This event will also decrease gluconeogenesis, which will decrease the blood glucose, and our muscles will then turn to the anaerobic metabolism, increasing lactate production. Hereditary fructose intolerance is the correct answer because the administration of epinephrine, we would see this increase of blood lactate, where I believe epinephrine would not affect glycogen storage disease, the lactate anymore, since the process is already occurring without epinephrine. Thank you for listening, and that is my recording for case study 2 for Unit 2.